நீரின்றி அமையாது உலகெனின் யார் யார்க்கும் வானின்றி அமையாது ஒழுக்கு. In the tapestry of life, water is the precious thread that sustains us all. From the majestic rivers that carve their paths through nature's canvas to the faucets that bring forth its life-giving flow, water is the essence of our existence. But have you ever wondered about the journey the elixir of life undertakes before reaching our homes, industries, and fields? We, the students of PSG Institute of Architecture and Planning, set forth to the Velliyangadu water treatment plant to gain insights into the process of how this precious resource is transformed into a safe and sustainable force of good. Come, join us. The water treatment plant, in close association with the Pillur Dam, was established in the year 1995 and is vital for the supply of clean, potable water to Veerapandi Pirivu, Kattachipalayam and Pillur. In this documentary, we explore the different phases of the treatment process that help the people of the region access safe water. The first step of screening takes place near the dam as the water flows towards the water treatment plant. To protect the main units of the treatment plant and to aid in their efficient operation, it is necessary to use screens to remove any large floating and suspended solids present. The water is collected through pipes from the dam after screening by virtue of gravity. We then move on to sedimentation, the first process that takes place in the plant. It is the removal of insoluble suspended particles. Particles that are denser settle down at the bottom while the collected water is allowed to pass through a velocity breaker through which it flows radially. The velocity then is largely reduced and the water enters the pre-settlement tank, which is a series of 8 tanks, 6 of them being in use 24/7 and 2 serving as standby tanks. Measuring 60 meter in length, 12 meter in width, 3.5 meter in depth, the tank has a capacity of 25 lakh liters. It will take about 3 hours for the water to travel from one end of the chamber to the other, allowing the suspended particles to settle at the bottom. There is minimal level difference at the end of the tank to increase its velocity for the next process. The water from the pre-settlement tank is then transported through pipes by gravity to the aerator. Aeration is the process of exposing water to air to remove dissolved gases such as carbon dioxide, volatile organic chemicals, and to oxidize dissolved metals like iron. The aeration process brings water and air into close contact by exposing thin sheets of water to air. Sweeping or scrubbing action caused by the turbulence of water and air mixing together oxidizes certain metals and physically removes the undesirable gases like hydrogen sulfide from solution and allows them to escape into the surrounding air. Once oxidized, the chemicals fall out of solution and become suspended material in the water. The suspended material can then be removed by filtration. The efficiency of the aeration process depends almost entirely on the amount of surface contact between the air and the water. The water is sent into the chlorine house. Chlorination is the addition of chlorine into water, usually to achieve disinfection and corrosion control. It can be applied as pre-treatment, such as in pre-chlorination, or the last part of the water treatment process, like in post-chlorination. In pre-chlorination, chlorine is added to the raw water prior to flash mixing and post-screening. The excess chlorine is beneficial in aiding coagulation, controlling of the growth of algae, reducing odor and mud ball formation. Moreover, it can produce prolonged contact time when added during the start of the water treatment process. The next process that takes place is coagulation. The finer particles that are suspended in water, those that are less than 1 micrometer in size, are removed by the addition of a chemical called a coagulant with a positive electrical charge is added to neutralize the negative charge of the suspended particles. The coagulant's addition takes place in a rapid mix tank where a high-speed impeller rapidly disperses it. Since their charges are now neutralized, the fine particles come together, forming soft, fluffy particles called flocks. The two coagulants commonly used in the treatment of water are aluminium sulfate and ferric chloride. After disinfecting the water using alum, the water is channeled into the clariflocculator using the dividing chamber. The process of flash mixing is used during the rainy seasons when the water is turbid. To clear this water, alum is supplied through the coagulation pipe in the flash mixer and mixed using the impeller. The inner tank of the clariflocculator, known as the flocculator or the flocculation tank, has a bridge which has metal plates called flocculating paddles attached to its bottom. In the clariflocculator, as the water enters the flocculator, when the bridge rotates, the flocculating paddles start to rotate and collect the sludge. Due to the conical shape of the clariflocculator, it has a slight slope towards the center, because of which the sludge slips down at the center. As heavy particles settle at the bottom, the liquid flows radially upward in the clarifier zone through small holes present in the walls of the flocculator. These holes help to reduce the velocity of the water. The outer tank provides a calm environment, allowing the particles to settle out of the water to form a layer of sediment at the bottom of the tank. It must be cleaned regularly to remove any debris, which is typically done by draining the tank and then manually removing the sediment with shovels or other tools. During filtration, the clear water passes through filters that have different pore sizes and are made of different materials such as sand, gravel, and charcoal. These filters remove dissolved particles and germs such as dust, chemicals, parasites, bacteria, and viruses. Activated carbon filters also remove bad odor. There are 18 filter beds in which 12 are functional while 6 are in standby. The relatively large suspended particles get stuck between the sand grains as they pass the filter media through mechanical straining process. The filtering capacity is 100 to 150 meter cube per meter square per day. 98% filtration is done after the process, in which it removes dangerous contaminants and suspended particles. Post-chlorination is the addition of chlorine towards the end before the water reaches the distribution system. Water distribution systems consist of an interconnected series of components. They include pipes, storage facilities, components that convey drinking water, pipeline distribution networks, dead-end distribution system, grid iron system, ring system, radial system, type of pipe material for pipelines for water distribution. With what the water reaches the people of the region, helping them with their domestic work and livelihood. The essence of life, water, flows through every aspect of our existence and reaches homes and industries after a series of steps from screening through filtration to distribution. Every drop is priceless in its own right. We express a profound gratitude to the experts on field in the Vellangadu plant, Mr. Ramesh and Mr. Sendalnathan, faculty in charge, professors, architect Tanushnath and architect Hemambika, and principal, architect Tamilvanan, for their support.